All right, well, welcome to If These Ducts Could Talk, Active Air Quality Management. Before we get started, a huge thanks to our top tier sponsor, Build Equinox. Build Equinox makes smart ventilation with a built-in heat pump system to get full energy recovery, full comfort, 100%. It's made right here in the United States, Urbana, Illinois, and 100% solar powered factory. Basically, what it does is it detects poor air quality around the house and then ramps up to exhaust that air quality when the home is polluted, and then runs a little bit lower when there's better air quality, so saving energy and saving money for your clients. They now have the Serve 2, which has been updated, and this can pair very well with mini split systems like our friends over at Mitsubishi, or they have a ground source heat pump system like our friends over at Water Furnace. And they can pair very well to distribute heating and cooling around the house and use it as people need it. So check them out over at buildequinox.com for the Serve 2. And then also thanks to our second tier sponsor, Indo Window. This is storm windows rather on the inside. You can improve window performance with window inserts, feel warmer in the winter, cooler in the summer, while saving up to 20% on energy bills. Third-party studies show a 10% reduction in air leakage to whole home improvements. These are do-it-yourself insert windows that are made of acrylic panel edges with a soft patented silicone compression tube that presses right into the window. Check them out over at indowindows.com. All right, so if these ducks could talk, we're going to jump right into that here shortly. The session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. This course, like many of our courses, are approved for multiple continuing education units, as well as AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Also, our friends over at Passive House Institute US, CEU approved, and our Certified Green Home Professional designation under energy and health pillars. And before we jump into the session, again, we're wanting to talk a little bit about the context of green building certifications for the CEU approval and LEED certification specifically. And what we're looking at and how these will fit into that context is something called the ASHRAE 62.2 standard. And that can be under the year 2010 or 2016. So if you're following LEED version 4, there's a prerequisite. And then we also have some of these same prerequisites in our Green Star program. For ventilation control, right? We want to have a healthy home. And so part of ventilation control is local exhaust systems. So like your bath fans and your kitchen range hoods, very important to get right. But also we need a total unit or total home ventilation strategy. That can be exhaust only, supply only, balanced, or ideally balanced plus smart, or smart demand controlled, which we're going to talk about today, plus a whole home approach. And so the way that it works with LEED is that they're looking at ASHRAE 62.210 for V4, typically for multifamily housing. And then for the latest version of LEED, which is the direction we're headed, and what I highly recommend, is 62.2 2016. And so if you go down, there's a little cheat sheet chart down there at the bottom. You can see from USGBC's website, they try to help you out. These are the levels you're trying to hit based on how many people are living in the house, or bedrooms plus one usually, and then the square footage in the home. So you're trying to hit these particular levels to make sure that the air quality, CO2 is reduced, VOCs is reduced, and other things with your ventilation strategy that you use in the home. And so we're highly advising the use of 16. And when it comes to demand control, that's where we're going to talk a little bit about where that comes into play and how that's different than this standard, in some ways better. And in some ways, I would argue they work together very well if done correctly. So LEED is requiring that you achieve those on your projects. Green Star is requiring that at the higher levels of certification. And the smart control and demand control I think is the direction we need to head. And we're challenging many of these green building programs to start to adopt those systems. So with that, I am super excited to introduce you to our speakers today, Kevin and Lucy over at Haven. I will have them introduce themselves in the organization, and please take it away. Welcome.
I totally need those Indo windows. I just as a quick preface, I just put the plastic up over my windows because they're so leaky, and it's actually saved me a bunch of money this last month since I put them up. I was really surprised. Anyways, my name is Lucy. I've worked for Haven for almost 6 years and have seen a huge portion of the roller coaster ride that we've been on. During that time, my role has changed from user experience designer to now product lead. So I'm used to getting really into the weeds, and also have learned to zoom out and see the bigger vision and keep that in mind. So I think one of the things that keeps me energized about our company is how much we value engagement with our users. Our focus for building our product is high performance and building science HVAC pros. These are the folks that really have been guiding us in our product development efforts over the last few years, since actually AHR 2020. We really see them as like the real heroes and are just trying to help them in any way we can, and also translate their detailed methods into scalable practices that feel more accessible to more middle market HVAC companies for solving their customers' problems the right way. I'll hand it over to Kevin here.
Thanks, Lucy. And I'm Kevin Hart, and I say the Canadian, not the comedian. And I'm the founder and CEO of Haven. We're an indoor air quality focused company. I actually started out just over 9 years ago in 2013, formerly an electrician, and moved into business and entrepreneurship and founded this company. And the original idea behind the company was to create low-cost sensors that could measure actually crystalline silica dust on work sites, which is carcinogenic and harmful to our health. And over time, that evolved into what can we control? And we can't necessarily always control the outdoor environment. We can wear our PPE, personal protective equipment. But what we really landed on, the big insight was that there are entire industry of heroes like these professionals at the forefront of building science in contained environments where we can control our indoor air quality and comfort. And so that's really a space and a lot of insights that opened us up to what we do today in the area of monitoring, but also now in the area of controls and automations and building templates and processes for solving IAQ issues. Now, we do mostly focus on retrofit. However, we work just as well in new construction. And we're happy to talk today about how this relates to demand control ventilation, to 62.2, and some of the stuff we've learned on this journey, because this has been quite a learning experience. It's a very complicated field. And to some extent, we've been on the forefront of maybe not perhaps the physics of building science, but certainly the application of indoor air quality projects. So we've had thousands of contractors who are Haven professionals. We've had thousands of installations, and we've seen a lot of stuff go wrong and some stuff go right. And we're leaning into, let's do things properly. How can we scale the things that are working with the few people who have figured it out across the nation?
Awesome. So here we go. What are we here for today? The 4 takeaways that I think we want everybody to walk away feeling a bit more confident in is understanding what we consider the 3 pillars of indoor air quality and the biggest issues that we see by climate zone and season. We've got the types of mechanical ventilation that are commonly used to address these issues in these different climate zones. The issues that arise when trying to sell, install, and manage IAQ in customers' homes. And finally, the tried and true solutions, like what Kevin was just speaking to there. What have we seen go right in these climate zones and with different combinations of equipment in terms of being effective in simplifying those IAQ projects, so that hopefully you can create a healthier home without too much of a headache. So just to set you up a bit, in the right context, the right frame of mind, the buildings that we live in essentially don't always prioritize human health. A lot of our time is spent indoors. You guys have probably seen that 90% of our time spent indoors stat in probably every indoor air quality marketing effort over the last 5 years. We're sick of it too, but it is true. And a lot of our spaces really don't have adequate ventilation and filtration. We've just lived through a pandemic, never mind all of the other airborne contaminants, bacteria, viruses, and mold that we deal with on a regular basis. And so the population is essentially way more sensitive than ever before, which is driving a huge demand for healthy homes. And while we see progress is moving in the right direction, energy efficient homes are built so tightly that this is creating a bigger need to manage that ventilation, the filtration, and humidity levels within the home. We are also seeing greater extremes throughout the seasons, and these are causing events like forest fires, which create spikes in PM 2.5 events that can infiltrate into our homes if it's like an older leaky home. We're seeing hurricanes, and the fact of the matter is that most of our homes just aren't built to stand up against these forces yet. And we hope that our buildings and the equipment inside them should protect our homes, our health, and our family. However, luckily, we are seeing that professionals do have interest in addressing this demand based on, as Kevin mentioned, like hundreds, if not thousands of conversations that we've had with pros over the years in many different fields. The specialty of implementing healthy homes is gaining traction, and we're seeing subsidies for heat pumps. We're seeing home comfort consults becoming a bit more common. Think like building material analysis, equipment load calculations, blower door tests, and of course, indoor air quality are also, all of these things are on people's minds. So the stakes of getting it right are getting higher and higher with the forces at play, and the consequences of getting it wrong could potentially cause more liability on the contractors and the designers that are speccing out and assembling these buildings. We see a fundamental part of any healthy home strategy as being able to manage the indoor air quality inside the home. Obviously, there are other factors at play, which we'll talk about later, but we really do believe in the 3 pillars, which we consider filtration, ventilation, and humidity control. And obviously, all of these pillars wouldn't be doing their jobs if we didn't have adequate circulation in the home. It really doesn't matter how good the solution equipment is if we don't have the ability to move that air, to distribute it throughout the home to the rest of the house. And what we found over the years is high humidity is really something that most Americans face. Well, most North Americans will face throughout the year. Like we're focusing more on the high humidity issues, but low humidity is also a problem in some of the drier and northern climates. And despite what some might gravitate towards regarding high humidity, it doesn't just affect humidity control strategy, it also severely affects the home's ventilation strategies too. All right, should we swap over, Kevin?
Yeah,
Just
I'll
stop
take it
sharing.
over. So there's a YouTube video that goes into great detail about 80% of Americans, I'd say North Americans, live east of the 100th meridian, which is kind of now shifted to the 98th meridian with climate change and all the changes in our climate. What we see here is that the vast majority of people are living in high humidity. And part of the reason, and you can watch this video and go into the details of it, but part of the reason is that you have the Rocky Mountains. A lot of the humidity flowing in from the East Coast can't make it past the Rocky Mountains due to their elevation. And so you just get this sort of dry area to the west, with the exception being the coastal regions, where you have a bit of a marine climate, particularly towards the north. And so this is a very unique type of geography and climate as a result. The vast majority of Americans, somewhere around 250 million, live in an area where high humidity is a problem. And the next part of that is it's also where the highest population density is. And you can see this is one of the maps they provided in this video showing the lights from space. So this is a nighttime view just showing the density, the different cities on the east side versus the west side of the country. And so we can see that the biggest issue is humidity when it comes to indoor air quality in terms of how many people it affects, whereas dry climates affect a relatively smaller amount. It's still a very important problem, but this has informed some of our thinking as a company as to which problems to focus on. Also, some of the humidity issues we see cause some of the most severe issues. They cause mold and moisture issues, microbial growth, and some of the most severe symptoms and side effects for homeowners' health. And so this is a version of a map that you would probably recognize. And it's broken down. I think most people would know, I don't have to explain, but the moist zone is climate zone A. And so that's everything on the east side of that meridian. You've got the dry zone, that's B. And that's a not very populated section of the country. And you got that marine climate zone, and which is the C climate zone. Then you can also break it down, and this is where you get into the number side of the climate zone. So anywhere from 1 being the most south and the hottest, all the way up to 7 on this map, which is the coldest region. And so it's broken down by moisture and by temperature. And we like to draw attention specifically to this sort of range of 1 to 4A, where you have a lot of the population in hot, humid environments that can provide a very tricky indoor air quality for these individuals and occupants. So breaking this down, the issues by climate zone. So what we see in the marine climate, and that's climate zone C, is we don't get a whole lot of runtime. And the reason we don't see a lot of runtime, and we see this in the data, and you can look at cold degree days and heating degree days, it's just because it's such a moderate climate. You get areas like Los Angeles, all the way up to Oregon, and up to where we are in Vancouver in Canada. And the temperatures outside are often not far away from our indoor set points. And so you're not going to get as much runtime versus somewhere that's 100 degrees plus Fahrenheit, where your air conditioner is going to be running constantly. Or areas in the central to eastern climate zone 7, where you would see that there's a lot of heating runtime. So because of that, the system's not turning on. You're going to get less filtration. You're going to get less ventilation in a lot of those scenarios because the equipment isn't functioning. Now, it's also one of the best climate zones for air quality because the delta of temperature inside and outside is so close. You technically can get a lot of ventilation if you have a dedicated ventilation system, and you can have some of the best air quality in the world, with the one exception that forest fires are prevalent in this area. And so we see a lot of particulate events, particularly in the summer, where it's quite an issue because you have to shut your ventilation off now. You can't bring in that outdoor air unless you filter that outdoor air first. But we see a lot of people just shut off their ventilation for potentially multiple months during the year. And therefore, not only are they getting low runtime on their HVAC equipment, and so not getting a lot of filtration or runtime and air mixing, but they're also not getting any ventilation. So they go from the extremes of the best air quality in the world to the worst air quality in the world, depending on the season. You then go into the dry climate zone, and you see that it gets so dry, and there's a lot of infiltration and a lot of the leakier homes that really dry out. You get shocking when you touch things, you get bleeding noses, you get headaches, you get all the symptoms associated with dry climate. There's a lot of ventilation issues because of the extreme delta T between indoors and outdoors. There's a big energy penalty to bringing in that cold outside air if you're on the 7 zone, or that dry indoor air, and having to rehumidify it. And also you do get in the more cold climates, you get combustion, you get furnaces, and that can sometimes lead to carbon monoxide and other combustion related chemicals inside of the home. And it's a perfect environment for anything passive, anything tight. Getting homes that are tight is critical in some of the colder and drier climate zones, because that's going to mean that you don't have sweating windows and some of the effects of dew point condensing behind your walls. So that extreme cold infiltration is probably the biggest issue in that climate zone. And then finally, climate zone A, which we've identified as being the majority of the population and IAQ issues we see, is one of the most difficult. And what you see, first of all, is that the air conditioners that are running are pulling some of the moisture out. They're acting as dehumidifiers. And so that condensate management becomes really important. You get clogging of the ability to pull that moisture out, which leads to flooding of the equipment, shutting off emergency safety switches, triggering, leading to a no cooling call. And you also have little ventilation because you're bringing in very hot and humid air. And so a lot of people will go with the minimum ventilation, and some people go with no ventilation at all, because it can cause a lot of microbial growth and mold and other issues. So a lot of this humid environment, you're dealing with water, you're dealing with moisture. That's some of the most complicated and damaging issues. So that's definitely the biggest issue in this climate zone. You also see, depending on the air velocity going through the HVAC system, you may see that the coils of the air conditioner are going to freeze up. And this can happen because someone doesn't change their filter, and the extreme runtimes, because the environment is so different outside than inside. You have a lot of runtime that clogs up the filter. It clogs up the evaporator coil full of dirt. It clogs up the condensate drain full of gunk. And that results in all sorts of downstream issues where maintenance becomes more important. And maintenance is critical to indoor air quality. So how do we solve for these 3 pillars of filtration, ventilation, and humidity issues? The first, on the filtration side, obviously filters, media air cleaners, cabinets. The deeper filter is typically a better solution because it will last longer without needing to be changed, has a higher surface area, so it's going to capture more particulates, and you can go up to a higher MERV rating to have a more efficient capture. We also see that gasketing and having a good cabinet is key to good filtration, and that typically would get installed on the air handler. But there's actually filters in everything. There's typically filters in your ERV, HRV. There's filters in your humidifier, dehumidifier, and there can be filters on your outdoor air duct. So it's amazing all the places that you find filters now. Ventilation, what we see, and first of all, the air handler goes across all of this because you don't get any of these without moving the air. You cannot filter particulates out without moving air through the filter. And so with ventilation, you have something as simple as just bringing in outdoor air as the air handler is running passively, and that can be a certain minimum CFM, which might be defined by ASHRAE 62.2. But you can also put a motorized damper on that outdoor air duct for the ability to either bring in more air than the minimum to offset a higher chemical event or a higher period of occupancy. and then turn it down to the minimum, or even turn it down temporarily to off if you have a demand control ventilation system. So that motorized duct is important. You've got powered ventilators. This is just the ability to push in outdoor air without a heat exchanger at a higher CFM. And then you've got HRVs bringing in a balanced ventilation into the home, but without a enthalpy membrane. So the ERV is something that's going to retain more moisture or maintain the relative humidity inside of the home better than an HRV due to that membrane. And so that almost borders on being something that helps control humidity, which is why we put it across the two sections. For humidity control, I'm not sure how many people are in the world of heating and cooling, but air conditioners are dehumidifiers. They do a great job at pulling moisture out of the air when they're running. And the dehumidifier is a optimized version of an air conditioner for that purpose. It's a dedicated dehumidifier. Here we're talking about whole home solution. So we're talking about a whole home heat air cleaner, a whole home dehumidifier, and a whole home humidifier. So something like a steam humidifier or a reheat dehumidifier. And these are various ways to control humidity. There's solutions like desiccant and a ventilating dehumidifier at the bottom here. So going into, and unless, by the way, we have any questions, because I'm not seeing any in the Q&A.
Nope, we're good. Thanks, Kevin.
Okay. So this is the typical workflow of someone tackling an indoor air quality issue, or attempting to today. And so this is number one, you have to identify if there is a problem. And this is on the reactive side, or sorry, the sort of retrofit side of things. So if someone already is living in a home that's built that has an issue, we're seeing on our side that there's a lot of calls from homeowners. There's an increasing demand and awareness of issues related to indoor air quality. And that might have already existed in the past, but the awareness that's been created, people can now properly identify, maybe I'm not sick, maybe this isn't a virus, maybe this actually is just a stuffy environment, meaning high CO2 levels, a tight home, not getting the proper amount of ventilation. Maybe I'm getting headaches, not related to something biological, but something related to my environment affecting me. And so we're seeing that there are a lot of calls happening, and particularly to the heating and cooling industry and professionals who oftentimes don't know what to do about it. And so first you have to identify if there is a problem, and you often are operating on very little context at this point. You can also be proactive. You can ask people, do you have an indoor air quality problem? Is there anyone in your family with asthma, allergies? Is this something you'd like us to explore? And this could come in as a comfort call, and then it can be converted into an indoor air quality discussion. More on the proactive side, on the design, engineering, building side, this can also be something proactive, either because it's part of the code and regulations, or it's something that you want to market as part of a new construction project. And so the next part is coming up with the best solution. And often what we've seen, especially through the pandemic, is a lot of people don't have data. And so they are getting called into a home, the homeowner asks for a solution, and they're being sold a solution. So salesman comes in and says, ma'am, you have a headache? Well, it's your lucky day, because we've got, you know, this blue light on sale today, and we'll put it in your duct and it'll solve all the world's problems and cure cancer. So convincing the homeowner to spend money to fix something without much evidence typically isn't very credible unless you really overpromise and oversell the outcomes and claims as a result of what you're doing. And often this isn't grounded in science or evidence, and it's even hard to prove either that there was a problem or that you solved the problem, which is why it's been fairly prolific. So how do you know if you need better filtration, ventilation, or humidity control when you're in a home? Maybe the home's newly built, maybe the home's been around for a while. How do you know? And what is the best approach? What is the solution that you're going to come up with? Our first principle is do no harm. So even if you do identify, somehow magically you locate this is the right pillar we're going to address for the problem happening, it's difficult to solve it without looking at the bigger picture. So just speaking to the complexity there, as you're speccing a solution. Again, we're a little bit biased to the retrofit side of things. There's all of these relationships. This is complicated. This is blowing our mind. At first, we thought this was simple. This was just throw a filter at a filtration problem, throw a dehumidifier at a high humidity problem. Simple. No, it's a lot more complicated than that. So first of all, the climate zone is the first part of this. So if you're looking at the outdoor conditions, your climate zone sort of dictates what those outdoor conditions are. And is it hot? Is it humid? Is it dry? Is it cold? What is the dew point? What is the outdoor air quality? Can we bring in air if there's a forest fire? Or if the homeowner lives right next to a roadway or a highway? So those are all important points. The building envelope is incredibly important to what you recommend. A leaky home versus a tight home may need a different solution. And sometimes the solution isn't what you think it will be, which is what we found. Sometimes just fixing the building envelope solves the IAQ issue. Sometimes solving the building envelope problem means that another part of this is the actual equipment, the heating and cooling system, now goes from being properly sized to oversized because we fixed the building envelope, and now we're not getting runtime. The indoor conditions. So as a result of occupancy, the humans, the pets, maybe the insects you don't know are living in your home, the human activities such as cooking, the materials, all the materials in our home are off-gassing. This is something I don't think, it took me years for this to really set in. And Joe Allen from Harvard wrote a book called Healthy Buildings, where he goes into detail in this. But pretty much everything we buy and we have in our home is off-gassing chemicals at some rate. Off-gassing formaldehyde, benzene, toluene, all these different chemicals. So some level of continuous ventilation is important in order to get rid of those, or else we're breathing them in. And if we don't have any way of changing the air, exchanging the air with outdoor air and ventilating, those build up to harmful levels, toxic levels that we're chronically breathing in for years and years and years and potentially decades. And while that may not cross a level of urgent toxicity on any sort of chart, over time, it does have a chronic effect where it's taxing your immune system, where it's taxing your body's ability to solve other problems that it should be solving, because it's distracted by all the chemicals and all the repair it's having to do from all the chemicals. So I'm going to say something really shocking here and abhorrent. Almost all IAQ solutions are controlled based on a temperature sensor on your wall. Rick Sims calls this the hope-based control strategy. So how can you dehumidify the air if your air conditioner is off and your dedicated dehu was linked to your central air system? How can your filter run if the central air handler that's controlled by heating and cooling calls from the thermostat, it is off? You're not going to get filter. How do you get ventilation if you have passive ventilation through your air handler and that air handler is turned off because the set point is satisfied? And so HVAC runtime is incredibly important to all three pillars, and doesn't happen often unless you have a properly sized piece of equipment in the right climate zone, with the exception being something like a dedicated ERV system, meaning it has its own ductwork, it's running on its own without the HVAC system being tied to it, without being interlocked to it. All right. So number 3, and this is one of the most surprising things. We've identified the solution to the problem, assuming all that was correct, assuming we somehow landed on the perfect solution. We've seen some things happen at the point of installation, at the point of controls, at the point of setting set points, where, again, things go sideways. And so, for example, not understanding that a system and all the components of the system need to work together. In Denver, this is a specific example that happened about a year ago. We walked into a home. It was a show home. This was from a new home builder in the Denver area, very proud of the indoor air quality setup that they had. So we were monitoring the indoor air quality in this ideal perfect show home that had a lot of time spent on it to get it perfect. And there was magazines taking photos, people walking through, mechanical engineers walking through to look at this home. We noticed that the humidity was very low, and this was during the winter, and had a nice big April Air whole home humidifier. The humidity was under 20%. It just wasn't maintaining any sort of indoor humidity levels. So that triggered us to go out and take a look, try to identify what was going on. And what we found was that the humidifier looked like it was turned on. The 24 volts showed lights and it said it was turned on and the controls were activating. But the actual humidifier solenoid, nobody pulled the 120 volts to the actual humidifier unit. So nothing was happening. And so these are just simple miscommunications among subcontractors and the ability to sort of audit the installation and the commissioning and the work that these people are doing. And so relying on sort of, again, a hope-based strategy that everything is what you think it is sometimes doesn't work. And how do we know? Another one is installing dehumidifiers. Sometimes dehumidifiers can be installed incorrectly. So there's various different types of installations. There's something called a dedicated return to supply. There's something called a return of the central air handler to supply. There is a supply to supply version of the installation. And there are some people who do what is not recommended, at least for certain types of dehumidifiers, which is a return to return installation of the dehumidifier. And what that effectively does is it heats up the air on a reheat system right before it enters the evaporator coil of the air conditioner, and it makes the central air conditioner ineffective, and it makes the entire system ineffective, and it increases your energy bill substantially because it's constantly producing hot air and making the air conditioner run constantly. And so that's one example of you can do it wrong. There's many cases of dehumidifiers being installed wrong, and the only reason it was noticed is because the energy bill skyrocketed and the homeowner noticed that. What we see also is that there are ducts sweating. So the actual ductwork is dripping wet. And often the solution in heating and cooling, the technician comes, especially in a hot and humid environment, and they close the ventilation. They close the damper, they shut it. They say, this will solve your problem. And so sometimes when you don't know a proper solution, shutting off ventilation, keeping that high humidity outside of the home ends up being the go-to when there's an issue. And of course, we often see heating and cooling equipment is oversized, meaning there's going to be low runtime, and there's going to be indoor air quality issues, and there's going to be comfort issues as a result. So there's many opportunities to make a situation worse rather than fixing it. Final point on the typical workflow of indoor air quality projects that we see is that once the project is done, how do you know it's working? Maybe initially, but after the first hour that you're gone, after the first week, and what about the lifetime? So all these things have filters. It's great if you achieve a certain standard, 62.2 LEED, but what happens a year from now? Does anyone know what the performance is? What if that equipment stopped working? And many of the filters get clogged. Many homeowners don't know what an ERV is. If they buy a home that has an ERV, they don't understand what it is. They don't know that it has a filter. They don't know the filter needs to be changed. In some of the most progressive indoor air quality projects we've seen, and even in new construction, there can be 8+ filters in a home. Some of them are proprietary sizes. With the supply chain issues we've been seeing, some of these filters are actually hard to even order and get in a reasonable time frame. And so how do you even maintain a indoor air quality, a healthy home with all these different pieces of equipment and filters? And how do you know? How do you know that things have gone sideways and aren't being maintained or working properly? All right. At this point, I will pass it back over to Lucy unless there's any questions to address based on that.
Thanks,
There
Kevin.
was just some discussion here again about when to select ERVs versus HRVs. If you wanted to, I know that's not necessarily what this talk is about, but it is incorporated. Do you have any further thoughts on that?
Yeah, I mean, disclaimer, we're not a ventilation manufacturer. We're not experts on that. From what I have learned, the enthalpy core of an ERV is going to recover not only some heat, but it's also going to recover some total energy or enthalpy across the ventilator, meaning your total output of a heating and cooling system, for example, is not only the sensible change, so the change in what we feel in terms of temperature, but the latent, and the latent being the amount of moisture. Mm-hmm. So what is the work your air conditioner did? It did both the work of removing moisture, and that took effort, that took energy, but it also changed the temperature. And you can actually change the work that an air conditioner does depending on the amount of CFM moving through the system. You can adjust the sensible to latent ratio to say, I'm in a dry climate. I care more that this air conditioner is sized only for the sensible portion of the load to get my set point, because I'm in Las Vegas and I want a cold home, but I don't want to remove moisture. So I'm going to bias towards a totally sensible ratio of this air conditioner versus latent. I live in Florida. I want to actually bias this air conditioner to removing as much moisture as possible, while now having to work longer and harder to hit the sensible portion, because it's now splitting its work between those two things. Similarly, an ERV is doing a little bit of work on the latent side by recovering and holding some of the moisture inside of the home and not letting it escape through to the outside, and vice versa from outside to inside. So it's sort of maintaining the status quo a little bit better in terms of the moisture and humidity than a HRV would be.
And that tends to be why the ERVs are so good for those dry climates, because we don't want to be pulling a lot of moisture out of the air. We just want to be introducing fresh outdoor air, and then the HRVs more suitable to the temperate, humid climates where you don't need to worry about the sensible load.
Yeah, like for example, California is a great climate for an HRV because the outdoor conditions are fairly similar, and exchanging that is fine. ERVs tend to be a little more expensive. I've also heard that depending on if it's winter or summer, sometimes a climate can switch from it would have been better for an HRV to it would have been better for an ERV. Actually, HRV and ERVs are so similar that the only difference is the core. And there's been in the past manufacturers who made an exchangeable core. So in one season, you put the HRV core in one season, you put the ERV core in. Unfortunately, all manufacturers seem to have gone away from that concept. So you're kind of stuck with your choice, regardless of if it had been better in a different season.
I wonder how much it costs for a pro to come in and do that change.
Yeah, it's just not even possible.
No.
Due to manufacturers. No, there was no uptake on that feature, so they just ditched that feature.
All right, so we're just going to talk a little bit about room versus whole home approaches. We feel very strongly about this, but there's also a time and a place for room-based approaches too. They've gained a lot of popularity in the last years and are appropriate for certain scenarios. But as the sort of basic illustration shows, it can take a lot of equipment and a lot of monitoring to reach all the rooms of the home that we care about. There's this huge upfront cost that's involved, plus the ongoing cost of maintaining them over time, as Kevin mentioned earlier, especially with all of the the shipping delays and whatnot, getting your hands on these proprietary filters can be a problem, and it can be costly at the end of it. A lot of the purifiers that we see out there, or dehumidifiers, they have their proprietary filtering systems, and they're on a timer. So it doesn't even matter how much dust they've collected. It tells you to change it, and most people will, depending, or like not considering if that filter is actually loaded or not. I should say what's good about these room-based pieces of equipment and the strategies is that they are making more homeowners aware of indoor air quality problems that can exist in a home. So while it might not be the best solution to address the problems, they are a good starting point to get people's feet wet, to get them familiar with the concepts of filtration, dehumidification, etc. So as I was just speaking to, a home has more than one room, which is why we want to be monitoring and controlling the air in throughout the entire space. A bedroom we do see as one scenario that could benefit a lot from having room monitors. Specifically, when the occupants are sleeping, we want to make sure that CO2 levels are being regulated properly, whereas the rest of the home could be set up in a whole home approach. Obviously, the kitchen will have a different reading than a bedroom, basement, etc. And what we see with room-based monitors is that they're at risk for being tampered with. People might start finding the little lights on them annoying and put them in a drawer where they can't actually detect anything anymore. And to begin with, they can probably only sense the immediate area around them. So if someone walks by and breathes on them wrong, like we'll see a spike in VOCs, which isn't representative of that whole room. They can also be tricky to maintain over time. Apart from the filters and whatever else you need to replace in them, the monitors themselves, they have these tiny little fans that can get clogged with dust very quickly, something that a homeowner probably wouldn't understand how to take apart, clean properly, and then reassemble so that it can continue doing its job. And while these room monitors have good quality sensors a lot of the time, they're not the most reliable solution for the whole home. So the data that we're getting from these multiple room sensors gets harder to work with, more to maintain, more to go wrong, and it just adds complexity that we've found is even hard to communicate on a whole home level, let alone a room level. So what we see as being kind of the ultimate strategy here is having a centralized indoor air quality strategy where we have a monitoring system that is in the ductwork, that is seeing the air that's moving. We can then trigger the equipment to move the air regularly. And not only does that serve the homeowners in terms of providing air movement and distribution throughout the home, but it also increases the potential for filtration and also increases the chances that the monitoring system can pick up what other levels in the home are out of whack. So we can then tell, do we need to introduce some outdoor air? Do we need to toggle the dehumidifier on? So we see this monitoring plus solution equipment plus the right controls to create this loop of solving the problem at the root, rather than just sort of a one-time activation that isn't reliable throughout how people's activities change in the home, from day to day, from season to season, etc. So this is kind of what we like to talk about as active air management. And this is what we see as a key component of any indoor air quality strategy. We need to consider how to integrate the equipment in the home already and identify what else is needed. So basically turning disparate equipment into an intelligent ecosystem. Think about an octopus with all of its tentacles. The octopus's head, like that brain, is what is we're seeing as like the monitoring system, and then each tentacle is a different way of controlling a piece of equipment to respond to a different type of issue. The problem that we see is that equipment isn't always aware of each other, and like in one home you might have several different brands that can't really talk to each other. So how do we then make sure that the system is working in a complementary way? We need to figure out how to interlock those pieces of equipment and intelligently control them so that we understand that they're contributing to a specific outcome, basically creating this whole home strategy. So active air management is not only what happens in the home, but also having the right professionals involved in helping the homeowner manage that system that they've set up. We don't see it as like a one and done situation. We see the pros needing to be involved over the course of years. So what we're essentially trying to do is like build this relationship between homeowner and pro, create a base level of trust where they can each point to the data and say like either the homeowner can start recognizing or be notified of certain trends going on in the home, or the pro can be notified and also have the conversation start in the other direction too. This goes into that remote management that I was just talking about. We see pros, one of their biggest pain points is installing equipment in a home and then leaving. They're basically hoping that everything is going to be operating as intended. But if they had some kind of method of checking in, of making sure from the comfort of their own desk that everything is working properly, how amazing would that be not to have to roll another truck? This is one of these like headache calls where a homeowner thinks that something is going on. Maybe their system it's been running overtime. The pro would be able to go in and just have a quick glance. Oh, here's what's going on. Like, let's have a conversation about that. I can export some kind of report that may indicate a recommendation for improvement, but it's that common ground for homeowner and pro to come to the table with. All right, so Kevin and I are going to jam on these next slides here. As we think about that timeline that he introduced before, that's like the typical workflow. And now that we're adding in active air management, we can see sort of the pain points that may have existed before go to the wayside a bit, because we are being proactive about solving the problems with real data.
Yeah. Thanks, Lucy. And what we see as the very first thing, if you remember the original workflow, it's figure out the problem. And so at this time with an IAQ monitor, and also some pros are using tools like Ecobee to be able to remotely pull some data from the home after they do an installation, they can actually look back. And what we're finding is that about a week is the amount of time that they want to just let things run and see how it functions after an install. And then confirm that it's not worthy of going back to the home to fix anything. So it saves them having to go back, and that's something they really appreciate. And we're doing something similar in indoor air quality, but this is actually even before that. It's how do we even diagnose the problem? How do we even choose the right pillar? And back to the point of there's all these issues of runtime and building envelope and climate zone. How do we actually select the right solution without having enough data? For example, data on the runtime, data on the chemical and particle levels happening in the home, data on how humidity is. And not only in the moment you're there at the home, but what about how it changes during the nighttime? If they've got a setback, so it gets colder at night, what about on the weekends? What about as the seasons change? So creating an initial diagnosis without data is very treacherous. And there's a saying, I believe, that you shouldn't make a diagnosis without data. That's malpractice, at least in the healthcare world. So Lucy.
Yeah, so like as we're sort of seeing in this graphic, this is in the scenario where we have monitoring installed already. So we can, like, when the homeowner reaches out to the pro, or if it is in the other direction, they have something to point to say, okay, like I'm feeling unwell. The pro can go in to their remote management system and be like, oh, well, it looks like as an example, your VOC levels have been in the poor realm for the last 2 weeks. Like, there is definitely something going on here, and there should be some kind of investigation to understand why that is, if it has changed over time. But also this can inform the types of equipment that they might suggest to the homeowner. And sometimes there are trust issues between homeowner and pro, so that's why we're trying to provide this sort of centralized system where they can both have the transparency to instill them with the confidence that this is the right solution. But if we are in a humid climate and we're seeing like high ventilation or high VOC levels, we can go, okay, well, we know that your home, because this is an existing customer, we know your home doesn't have as much ventilation as what we would recommend. So we are suggesting that you install a ventilating dehumidifier alongside an outdoor air damper to allow your home to be ventilated properly without the harm of introducing all this new humidity into the home.
Yeah, it's super important to know before you start tackling a project. We'd often recommend, a blower door test. First of all, is the home leaky or tight? And there may be ways to sort of try to assess that without a blower door test, but highly recommended. First of all, what climate zone are you in? What is your design temperature? What is the extreme hot and cold that's going to be experienced? What are the heating degree and cooling degree days? So get all the climate zone stuff out of the way, figure out how leaky the home is, figure out if the equipment is properly sized. Part of that can be done through looking at the runtime. How frequent is the system running? What are the heating and cooling cycles look like? How long do they last? A properly sized piece of equipment should actually run fairly long periods of time to distribute that hot or cold air and establish a mean radiant temperature of the objects in the home. And because it's running longer, you're getting more filtration time and more circulation inside of the home.
Yeah, so here's just a quick overview. I know we talked about it earlier with the ventilating dehu and damper, but just a couple of ways to visualize how this equipment might be set up, especially in these, like, as we mentioned before, we're specializing in the Southeast. So a lot of the HVAC systems here are just installed in a closet, and they don't actually have a proper return duct. It's just a grill and then equipment right away. So there's no actual place to insert the monitoring system, which is why we would install it in the return of a ventilating dehumidifier. Brett,
So,
do you have a?
So the system goes on the return side, not so pre-filter, is that true?
Pre-filter so that we can see the air at its dirtiest point, essentially. so that we understand what corrective action needs to be taken to fix it.
And do you also have an opportunity for post filter just to kind of get the pre and post?
We've done
Yeah.
we've done some projects where we'll look at the pre and post. Particularly, these will be like light commercial projects, kind of out of our normal ballpark of residential. We'll get into some, for example, food processing facility where they want to look and see what is the effectiveness of our system. And
actually what I meant was, do you try to actually monitor the supply side, after the filter as well, just to get the two data points at the same time?
Yeah, we do see that sometimes when there's a building owner, they care more about what is the air I'm supplying to the tenant. Whereas in single family, when it's the owner is the tenant, they just want to have a system that controls, and being in the return, we see what's coming back, we can control appropriately, and then it's cyclical. So whatever's happening in supply eventually circulates back to the return, and we can measure the effectiveness of what actions we're taking.
Well, you simultaneously answered another question in there. So you actually do have a service for light commercial, those who are using maybe more traditional systems that are like residential. When there's very similar to residential, and when there is a Wi-Fi network that isn't some crazy enterprise grade network, and also when there isn't a building management system, that's sort of where we play to our strengths, where we call ourselves sort of like the poor man's building management system, because we're attempting to do a lot of things a sophisticated BMS would do, but at a residential level without that BMS. Yeah. And there were questions about multifamily, which of course finds itself sandwiched in between residential and commercial, right? So you're saying if you've got these multifamily units with these individual duct systems, it would need like a master Wi-Fi to connect them all, or how does that work?
Yeah, I feel like that's an area that will be solved better in the coming years with new protocols like Matter, where devices can sort of have better interoperability and better connectivity on a mesh basis. Right now, it's a little unelegant to have to establish Wi-Fi networks and get devices across a building attached. And that's one of the reasons we've also kind of leaned more on the residential, slightly more on the single family side, although we have seen and been part of all sorts of projects.
Yeah. Thanks.
And Lucy, I feel like we're trying to say something, but to be very bold about it and maybe say it differently. In especially the hot, humid climates, there is a solution that we see some pros implementing that works very effectively to actually address all three pillars of indoor air quality. And that is a ventilating dehumidifier. And part of the reason it works so well is because you are ventilating outdoor air intake into the dehumidifier. So that air is already, even though it's very moist, it's already getting dehumidified through the dehumidifier before it's getting dumped into the supply duct. Now that air will be hot because it's been reheated and because it's come from outside. And so you're dumping hot air into a cold supply duct right after the air conditioner. And so you do need space for mixing. The air needs to mix properly before it gets distributed. So the one issue with this installation is if you do it improperly, the hot air will unevenly affect a room in the home because it's getting sucked into one supply branch. And now that cold room becomes hot because it's getting dumped all this hot air. So you do want a couple of feet, like ideally 3 feet of mixing before you start getting any branches off to the supply side. But one of the reasons this is so effective is it's going to keep the air handler and the air conditioner running longer because it's producing some of the heat with the heat pump. So it's very energy efficient. And so the air conditioner is going to be on longer. Your comfort is going to get better because the air conditioner is running longer and because you're better controlling humidity, and humidity has a big impact on comfort. So this is a solution that improves comfort. It's a solution that controls dehumidification. the dehumidifier stands on the shoulder of the air conditioner. So both of them now work better and more efficiently to remove moisture. So it's very effective at that. It's now ventilating in a way that that ventilation air is getting dehumidified. So you're not getting a lot of the issues of ventilation in that hot, humid climate that just pulling straight hot, humid air and dumping it into the home would otherwise create mold and other issues. And the ventilating dehumidifier, we're typically running it frequently, and it's got a filter inside of it. And some of them have even a MERV 13 filter. And so you're getting additional filtration, both of the outdoor air, but also of the dedicated return air running through that piece of equipment. So it's a good all-around solution where it addresses all three pillars effectively. And it usually works if you know a few of the installation nuances that can cause issues.
Yeah, so we're just being a bit more explicit here again. There's the ventilating dehu, which we know solves issues across all pillars. In an ideal situation, it's also running alongside an air handler so that we get that mixing, so that we have the positive effects of the AC. But then that motorized damper duct, we can really, like, the beauty of an integrated system is we can open and close the duct when needed. So integrating with outdoor AQI, for example, this was a question that came up in the chat earlier. If there are issues that cause the AQI to rise, if we have control over the damper, we can make sure that we're closing that off if outdoor air starts becoming worse than the indoor air. And essentially what we want to do is activate the equipment without doing harm. So this idea of demand control ventilation for residential, we've got that controlling of the motorized damper to only open when needed. And this is where our sort of basis, it can be installed sort of complementary with any ASHRAE 62.2 standards. We're ensuring, or a system like this should ensure, that the home is responding to events throughout the day so that we have more ventilation when we need it, and then we can fall back to the standard if that's what you've designed into your system. I just spoke again to the outdoor air data, so we're trying to make it a safer environment. And then also making sure that this is like one of building science and high performance professionals, their beef with humidity control is that a lot of humidistats are still controlling based on relative humidity. And like it's in the name, it's a relative parameter that isn't as reliable as something more absolute that indicates when condensation would actually be produced. So dew point is that parameter where we can have a much more exact level of control over humidity levels. So we want to get that solution equipment involved in solving the problems, but not at the expense of other levels inside the home. So back to our active air management workflow, that automation that I was just speaking to. If the pro has determined that we have the right solution equipment installed, and now we need to make sure that it's being activated properly. So we wanted to make that as easy for pros as possible by creating templates that can optimize based on outcome. So here's just one example of what we've seen of, I believe this was the ventilating dehu installed. We've got the automations working as intended, and now we can see those levels being brought down into a healthy range again with the right activations. And yeah, go ahead.
If you want to finish that, you can. There's just a question that
Oh,
you
yeah.
can ask.
Yeah, I'll wrap it up. It's really quick here. Ensuring basically after the equipment and automations have been set up, the pro can go away feeling as though they have insight over to what is happening in the home. They can do that check. They can reassure the homeowner that they've invested in the right equipment. Oftentimes, price is one of the biggest blockers for homeowners to actually invest in the right solution. So reaffirming their choices can be really helpful in solidifying that relationship into the future. We have a question.
Yeah, let's before we get to the questions, just real quick. Again, thanks for those of you who did join us and who are on here. Trying to share my screen, but I can't find it. It looks like I'm not going to be able to find my screen share. So just as a quick reminder, for those of you who have to get going, you're approved if you've been here for your entire continuing CEU series. For those of you watching this in the future on demand, not right now, make sure to head over to our Thinkific channel to take your quiz with an 80% passing rate, and you can receive your certificate. And for those of you watching live, check certs at gutenbergcerts.com, and you may be able to access your continuing education there and that way. And as a reminder on the lead side, again, Kevin pointed this out. It was, made it very clear. A lot of times our systems, they're not running all the time. So we see a lot of green building projects starting out trying to design their project around those run times and say, oh, I'll bring in that supply air from the furnace to hit the ASHRAE standard. And I say, well, what happens during the swing seasons, the shoulder seasons, and other times when you're not calling for demand? You should be right-sized if you're a green building project. And a lot of people are like, oh, I don't know, right? I don't know. So that's the solution we talked about here today, right? So we're going to want to make sure that it's having the ventilation system in place, right size to hit the ASHRAE standard, and then ideally adding on the on-demand component, which goes above and beyond for these green building programs. And the next level that we need to get to, you've heard us talk about it multiple times over several years. We'll keep talking about it, but ultimately, that is the way to go. So I think the question that came in here specifically was around smaller single family home renovations, and budget is very low, right? The budget always is very low. And so one thing I wanted to say to that part of it, the budget side, is Inflation Reduction Act dollars are flowing. They're out in Canada. You guys have some really cool programs that I'm still jealous of for green home remodeling. So maybe you can explain that. But so there is money, and it's coming, and it's going to help boost those budgets. There's also green mortgages that your clients can apply for, green banks that your clients can apply for. So the money is there. So setting aside the money part, let's get to the technical side. The question is there a way to specify HVAC system with a dedicated ventilation component without hiring an HVAC engineer to design the full system? I try to hire an engineer on all the projects. I'm an architect that I get involved in, but most often than not, these fees for the scope of work are just very high. So any insight you can give us on that?
I would just say, I mean, first of all, we're big proponents of using professionals, and they have a lot of skill and deserve to make some money for all their knowledge. That said, like, we also, our mission is healthy homes, and that's kind of from the perspective of the homeowner. And so I think an answer in the middle here would be, there's a lot of manufacturers who do want to engage. They want to sell their piece of equipment, and some of them are actually quite knowledgeable and quite helpful. And there's brands like Santa Fe and Aprilaire who are particularly engaged with their customers and want to sell you equipment and have resources available to give you recommendations. It's unlike heating and cooling systems, something like speccing a dehumidifier on a small residential single family home. It's hard to oversize it. You're also going to do some good if you undersize it. So as long as the installation occurs correctly, as long as the duct work and the points of installation and the method that you chose was good, the sizing specifically and how you design it, there is some resources that you can access through the actual manufacturers themselves. And I'd also say there's people that are engaged in the HVAC world. There's kind of influencers, there's podcasts where they do discuss their methods, techniques. There's groups like on Facebook, for example, where you can ask questions and get help from a community of professionals. And so there are ways to do things on a budget if you're trying to help a homeowner.
What do we do in the case? Well, let's kind of ask two questions here. You had mentioned, I think it was Lucy, you had said, the sort of these independent air quality monitoring systems, right? And we certainly highly recommend those. I mean, if only we could get people to start monitoring their air quality, however they do it. Like, let's just start there. But you made some good points. It's only monitoring what's going on in that particular room. But could you also say then, the particular system you're talking about is only monitoring what's going on right there at the exhaust or at the intake right before it goes into the filter? Could you flip the argument a bit and say, well, that's also the case. You're only getting that snapshot. And let me give you a scenario that occurred to me. I had my PM 2.5 monitor sitting in my bedroom in like one summer where massive wildfires were raging very far away from my house. We had our window open at night, our ventilation system turned off. And next thing I know, I wake up in the middle of the night and the PM 2.5 is just huge. And but it's only in that room. My other air quality monitors were not picking it up because the window was only open in that room. And I'm like, what's going on? And I shut the window and sure enough, I read the news that it was spreading all over here. So that's just one example where I kind of had, if it was perhaps in the duct system, would it have picked it up? Would I have even known? And so, and then how does that interplay with mini splits where there are no duct systems, and what do you do there? So, not to pick on y'all, but just, I mean, what are your thoughts on that?
We play at the level of the whole home. And so when there's a particular room, like often a bedroom, there's concerns, CO2 is going to be high during the nighttime. If your situation, maybe have a nursery, so you just care more about that room than other rooms. If you have a particular room of concern, there is an application for other products that detect and solve problems on a room basis. You can get HEPA filter, air purifier in a room connected to an air monitor. That's a great solution for a room. We're not saying anything negative or bad about that, but where we play is at the whole home level. So if you have whole home equipment, we want to know what's happening as an average across all the different areas of the home that are being controlled by that piece of equipment. So being integrated and integral to the duct system that is sensing what's happening through the ducts and then being supplied back from that equipment back to those same rooms is a good way to monitor, measure, and control that zone. And it is going to take, in general, averaged across these rooms. So what we say doesn't work, I guess what we're trying to establish is if you were to take multiple rooms that are in that same zone and distribute monitors across, you'd need 3, you'd need 4, you'd need multiple monitors. Now you're dealing with multiple points of data from multiple areas. Some of them are going to be measuring hyperlocal measurements. And so controlling based on those measurements is less ideal, in our opinion, than that approach. And part of it is those devices can be breathed on, triggering a CO2 response. It could be too close to something that emits some chemicals, or somebody could put it in a drawer or cover it with a jacket. So as a point of a signal, a control trigger for equipment located elsewhere, we believe that having that integrated duct approach is superior.
Yeah. So what is your thoughts, for those who are looking to install or use mini split systems or ducted mini split systems, which are very, small runs, right? Do you have solutions or ideas, for either of those approaches?
I mean, the mini splits, and part of the reason we focused on ducted systems is because you're moving the air. It's an air distribution system. And whenever you move the air, you have a lot of ability now to clean the air, to filter the air, to ventilate, to move outdoor air inside, to dehumidify. So when you're working with a mini split, we've even heard from the manufacturer of mini splits, one of them right up on your screen there, that they don't currently pull a lot of moisture out of the air. If you actually look at their condensate lines, it's like a pencil. They're barely removing moisture, so they're not really controlling humidity. They're more on the sensible side, despite what you might have heard. Maybe that will change. We hope that will change, and we've heard that there's some work going on to have mini splits that have a higher latent removal in the future, especially for those hot and humid climates. Mm-hmm. For that reason, we wouldn't recommend an entire system of mini splits in a hot and humid climate unless there's a dedicated dehumidifier, because you're not going to be able to control humidity correctly. Also, they tend not to have good filters because they can't achieve a good static pressure across that little blower. And so you can't throw a MERV 13, you can't throw a good filter. And maybe you could throw a 1 inch in there, but you're not going to be able to put a deep 4-inch filter with a lot of media on there. So you're not going to get good filtration, and you're not really going to get ventilation. They're not attached to any outdoor air. So really, mini splits don't address air quality at all. It just addresses the sensible temperature. We see a hybrid system is a good way to go, where the mini split tackles a specific room that you want to have at a different temperature, that maybe it's a band-aid for there's some other issue, like having a room above your garage, for example. There's a lot of building science issues in certain, or having a room close to an attic, which is unconditioned. So you may have specific areas of your home where a mini split makes sense, but for a mini split only home, or like a baseboard heat only home, controlling indoor air quality becomes really difficult. And that's why we've shied away from a solution in those types of buildings. And that's where maybe something like an air purifier, or a portable or a room solution makes sense.
Yeah. I've heard a lot of talk that, mini splits perhaps paired with ventilating dehumidifiers for the whole home is the strategy. I think earlier you were saying your system could be embedded in just the ventilating dehumidifier. Did I hear that correctly?
Yep. Yeah, it can go in the return side of that dehumidifier, because typically a lot of the recommendations, instead of going return to supply on the central air handler, you can actually do dedicated return. So you're actually ducting, maybe to like the living room, you're adding a grill in the living room, you're pulling that air through a duct. So it's called a dedicated return to the dehumidifier. So you can put the monitor in that duct on the return side of the dehumidifier.
Yeah. One thing I was really excited about in your talk, and more surprised to some extent, was, really not just sort of this, here it is, walk away, leave you, but there's this consistent follow-up, ideally, with the contractor. And I also heard on the flip side, there's, this idea that someone's coming in and solving these problems. And I saw that on the Q&A too. Questions about, hey, is there someone in my area who can come in and solve this problem for me? Because I'm trying to think, I don't know that many people that can solve these problems. I mean, I know a few. And so, most people don't know anyone. So are you all like working on any kind of trainings that people can take where they can just be empowered, know the tools they need to go in and diagnose these issues? Is it just HVAC? Is it also raters, or can you briefly describe, what your thoughts are there?
Actually, Lucy's been working on a piece of that, which is when you're setting up this equipment, and specifically we started with hot humid climates, we started with ventilating dehumidifiers. We came up with a template that anyone can follow, which actually shows a wiring diagram. It describes the approach we're taking, the solution. It sets up the automation and the controls. It says, okay, connect this relay to this blower, and then connect this relay to the condenser on the dehumidifier, and then the automations are already built. So this is going to control on dew point, not relative humidity. This is going to control on dew point. And here we're going to look at the outdoor air quality and control based on that. And so we've actually, first of all, we knew nothing, and then we learned from professionals, and then we took other experts, and we went to building science seminars, and we passed approaches by all the experts and pros, and then went, okay, let's create a template where anybody could follow this template. But that again is only a portion of the workflow. So where we need to, and we also have, after we have alerts, we have a pro portal, we have ways to know the solution is still working into the future, or something went wrong and you can get alerted. So we have a bit of the after and we have that during. What we want to get more into is the before. So if you say, hey, I'm in this climate zone and I've got a blower door test of this, and I've got this runtime and I've taken some before measurements, maybe I installed this monitor before I did the project to take a baseline. Now we can get to, we're going to actually help make a recommendation here. We're actually going to help you select the template and the approach you should take, because that's what's missing. Many contractors don't know enough to solve this. And so, like you said, homeowners struggle to find someone who can solve their problem because the information doesn't exist. And part of that is everyone's selling their thing. They're selling their filter, they're selling their dehumidifier. No one's putting the whole picture together and helping contractors figure out, in this specific situation, how do I solve the problem?
And that's the big part too. Like Kevin said, there are all of these other pieces that need to be a part of the strategy. It's not just the IAQ equipment and the controls. It's the work that they need to do before that to make sure that this is the right equipment for this specific home. So, I mean, the purpose of creating these templates is to almost find this easy button for the sort of more majority HVAC contractors out there to feel like, hey, maybe this is something that I can start approaching with my customers. Maybe I can start facilitating more IAQ projects in my business. But they still, like, and what Kevin said, we want to get more into like, what are the steps to be taken before the right template is selected for that home, so that we take the weight, some of like all of the work, all of the things that the building science experts, they've figured out the hardest way possible. And it's basically, it's just inaccessible for most people. So we're trying to break down those barriers.
Yeah, and I know we're at time. Kind of the last thing I'd leave you with is this vision that what we're trying to accomplish is going from this choose your own adventure of indoor air quality landscape, where people just don't do it because it's too complicated, to not only can we take the before measurements and make a recommendation and then know that that solution was installed correctly, but we can give the before and after picture to the homeowner and say, here's what you paid for. Here's the improvement you got. Here's the good, healthy air you got. We can show the before, we can show the after, and then we can make sure on an ongoing basis that that is still delivering that performance a year from now, 5 years from now.
Quantifiable improvement.
Yeah, well, fantastic. Kevin, Lucy, I really appreciate your time sticking around a little bit longer through us. I'm real excited to keep learning more and following what you all are doing and getting the word out. Again, just last minute, where can people go to either contact you or learn more if they want to get involved?
I mean, we've got our website is haveniaq.com. We're also on Instagram, Facebook. You can search for Haven IAQ, and we will be the first ones to pop up. We're always looking for people to join our beta program. So if you're keen to kind of be a part of the experimentation and validation process that we're going through, working with these building science experts, we highly value any professional input. So reach out to us if you want to be involved or if you just want to follow along on a public level.
Lucy, Kevin, Haven, go check them out. Thank you so much, everyone. Have a great rest of your week. We'll see you next week.
Thank you, Brett.
Thank
Thanks, everyone.
you. Thank you so much.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.